Everyone, so today we will be discussing about chemical kinetics, a very important topic in chemistry, and it will be important for your higher secondary as well as for graduation and post graduation and various entrance examinations like JAM, NET, CSIR, NET or GATE, right? So this is a crash course type of video where I will be discussing about various important formulas and equations that will be needed to solve various numerical problems. Okay, so the first is that let us consider about this kind of reaction, that is AA plus BB is forming C and D, and the stoichiometric coefficients are C and D. Okay, so let us take this is a basic reaction based on which we will be forming the equations, right? So the first equation about in chemical kinetics is what is rate. So rate is basically this. These four equations are important for rate. These are rate. What is this? 1 by a into d of a by d of t, and that is basically the decrease of a with respect to time. Now this a is stoichiometric coefficient, so the formula becomes rate. So the formula becomes like this. So rate is equals 1 by stoichiometric coefficient, any stoichiometric coefficient d of that particular component divided by d of t, that is time, with respect to time, right? And as these are the reactants, so these are decreasing with time, so here is the negative sign. Now as these are the products and it is increasing with time, so these are positive in sign, right? So this is rate. Another equation for rate is the rate equation. This is called rate equation, and it is written as k into concentration of A into concentration of B, and the power is m and n. Now this m and n may or may not be equal to m, may or may not be equal to A, also n may or may not be equal to B, right? This depends on the nature of the reaction, whether it is complex reaction, whether it is simple reaction. For simple reaction, m can be equal to A, right? And this is called rate constant, right? So this is a constant which is different for different reactions. Okay, so this is called rate constant. Now what is the unit of K? Unit of K is written as mole liter inverse, this whole bracket 1 minus n and second inverse. This n is nothing but the order. N is order of the reaction. N is order of reaction, right? So n is order of reaction. So let us find out for zeroth order reaction what will be the unit. Okay, I have written for zeroth order reaction. Let us write down the rate. What is the rate? So for zeroth order reaction, it is zeroth order because it doesn't depend on the concentration of the reactant. So the rate is dA by dt equals to k0. That is, we can write it as a to the power 0, as it doesn't depend on the concentration of the reactant, so it eventually becomes k0. Now what is the unit of k0? Unit of k0, we can write it as mole liter inverse 1 minus 0 second inverse, as from this formula, right? So this becomes mole liter inverse and second inverse. So this is the unit of zeroth order, unit or rate constant of zeroth order reaction. And what is the rate equation for zeroth order reaction? This is the rate equation for zeroth order reaction, that is A0, that is concentration of A, the initial concentration of A, and A is the concentration at time t. So A is the concentration of time t and equals K0 into T. So this is the equation for zeroth order reaction. And what is T half? T half is basically half-life. Half-life is at that time when the concentration, so half-life is when A is equals half of A0. So that is the half-life, right? At that time when A is half of A0. So this is A0 by 2 K0 for zeroth order reaction. Now come to first order reaction. First order reaction, so that is n equals 1, and this is the rate equation, that is k is equals 2.303 divided by k log A0 by A, and you know what is A0 and A now, right? And T half becomes 0.693 1 by K1. We can write K1 as it is for first order reaction. Now what is unit of K here? Unit of K is nothing but second inverse, right? Now you cannot derive this unit of K from the formula that I have given, but also you can derive it. It is not that you cannot derive. You can derive it how? You can write it down mole liter inverse 1 minus n. So you write down 1 in the place of n, and you find out that this becomes 0 and the formula becomes second inverse, right? So that so this is the unit of K. Now T half is very important. This half life for first order reaction is 0.693 by K1, and for second order reaction the rate equation becomes like this. So K2, as for second order reaction, 1 by T is equals to 1 by A0. It will be easy for you to understand. 1 by A minus 1 by A0, right? So this is the equation for second order reaction, and now let us consider this is the second order reaction for this kind of reaction. So one component is forming product, right? If there is two reactants, if there is two reactants A and B, it is forming the product, then the equation becomes different, and it becomes 2.303 by A minus B. A is the concentration of initial concentration of A, and B is initial concentration of B. X is extent of reaction, right? So how much reaction has been processed, right? How much reactant has been converted to product, and that is X, right? So this becomes 2.303 by A minus B into T log B into A minus X by A into B minus X. Now T half, that is half life for second order reaction, is 1 by K2 into A0. So there lies a question that for which n T half is independent on T. So the answer becomes first order, that is n equals to 1. For n equals 1, T half doesn't depend on initial concentration of it is independent not on T, but initial concentration on A0. So only the first order reaction doesn't depend on the initial concentration of the reactant, right? As you can see, the zeroth order reaction, it is A0 by 2K. For first order reaction, it is 0.693 by K1, and for second order reaction it is 1 by K2 into A0, right? Now let us come to for nth reaction. Right? For nth reaction, this is a general this can be a general equation that you can apply for any n value except 1. You cannot apply it for n equals 1, right? You cannot apply it for n equals 1. Now for K, this formula is Kn equals 1 by n minus 1 into A to the power n minus 1 into minus 1 by A0 to the power n minus 1. So this is initial concentration, this is concentration at time t. Now here is also written that this unit of Kn is mole liter inverse to the power 1 minus n second inverse, right? You have to memorize these formulas, and this is very easy to memorize. How, I will tell you. That is, n is first, so right, so n is a number which is not equal to 1, so it is not initial, so n is coming before 1, so the concentration at time t will come before the concentration of time time 0, that is initial concentration. So the formula you can write it by closing to i's as Kn equal 1 by n minus 1. As you have written n minus 1, so you will write in the bracket A to the power n minus 1 minus 1 by A0 to the power n minus 1, as you have written n before. And if you have written 1 minus n, so you have to write A0 to the power n minus 1 minus 1 by A to the power n minus 1. So that is very simple. You have to memorize this, right? So unit of K is mole liter inverse to the power 1 minus n second inverse. Now the T half for nth order reaction is T half equal to 2 to the power n minus 1 minus 1 Kn into n minus 1 into a0 to the power n minus 1, right? So remember, you cannot use it for n equals 1, right? You cannot use it for n equals 1. Otherwise, for any n value, these formulas are applicable, right? Now let us come to the temperature dependence. This Arrhenius equation is nothing but the temperature dependence of K, that is the rate constant. How the rate constant depends on temperature? Generally, it has been found that on increasing temperature, the rate constant or the rate of the reaction increases. Now, how it depends on the temperature? That is depicted by this Arrhenius equation, and that is the rate constant. K is equal to rate constant. This is Arrhenius constant. A is Arrhenius constant, right? K is Arrhenius constant or pre-exponential factor. Now, why this is called pre-exponential factor? Because it is coming before the exponential term, that is e to the power Ea by RT. Now, Ea is nothing but activation energy. Ea is activation energy. Now, what is activation energy? Activation energy is the energy that is required to for the reactants to get into the state where it can react, right? It can react, so it activates the reactants for reaction. So this is called, that is why it is called activation energy. So the energy that is required for the activation of the reactants to react is called the activation energy, right? So this activation energy will be different for different reactions. So this activation energy R is nothing but the universal gas constant, and T is the temperature in Kelvin, right? And this formula is will be derived as log K1 by K2 got Ea by 2.303 into R into 1 by T2 minus T1, and this is also same. You write log, then you write K1 and K2, K1 by K2. So this you are writing K2 below, right? You are writing K2 below. So you will write T2 first. So if you have written log K1 by K2 by K1, then this equation will become 2.303 R, as you have written K1 here, so you will write T1 here and T2 here. So the equation would eventually become this. So whatever you write in the denominator, you will write it first in the bracket, right? So now let us move to the derived derivative equation. This is d ln k by d ln t Ea by RT squared. This will be required to calculate the rate constant with respect to time. All these equations will be required to calculate the equation with respect to time. Temperature. Okay. Now, as I have told you about the activation energy, so what is activation energy? And let us consider as this extent of reaction. This extent of reaction is in the x-axis, and in y-axis let us put energy. So here this is the reactants A plus B, and let us write down this as products, right? A and A plus B has the energy at this position, and C plus D has the energy at this position. So obviously the reactants are in the higher energy, so any molecule that is in the higher energy will convert it to the lower energy. So any system comes to the lower energy and it becomes stable. So higher energy molecules are unstable, and that's why it will react to form lower energy molecules, that is stable molecules, that is C plus D. Now okay, so now how reaction proceeds is like this. The reaction proceeds like this, and this is not some such broad. This comes like, sorry, I am writing it as broad, but this can never be broad. Okay, you have to understand that these peaks cannot be broad. If it is broad, then there is some transition state involved. So transition states in these reactions, transition state I am not considering. I am just simply showing what is activation energy. So that's why I will not write it as broad, right? So this is the energy curve. So the A plus B is going through this. This is the activation barrier. This is the activation barrier, right? So this energy falls at this position, right? This energy falls at this position. At this position. So there is an energy gap here. So there is an energy gap here. And this energy gap is nothing but the activation energy. So the energy, once it achieves at this position, that is at the activation, this energy barrier position, it is highest in energy. So it falls down. It falls down to the C plus D energy level, right? It falls down, but it has to go to the higher energy state, and to bring it to the higher energy state, we have to give some energy from outside to the reactants so that it goes to the higher energy state, and that energy is the activation energy. That energy is the activation energy, right? That energy is activation energy. So this was the activation energy concept, and this was the first part of the chemical kinetics crash course, and you have learned about different equations that will be necessary for your competitive examinations like NET or GATE, and even in your board exams, right? Board exams or university exams, right? So that is it for today, and I will be coming up with the second part of the chemical kinetics crash course. So I will be discussing about various kind of reactions, that is parallel reaction, what is a consecutive reaction and their related formulas, and various theories of rate of reaction theory, various theories of reaction, how reaction proceeds, and what are the rate equations, right? Okay, so that is today. That is it for today, and I'll also like you to ask you for subscription and all, because this is a very new channel. It needs to grow up. If you like the content, you subscribe, and this channel will grow with you guys. Thank you.